Hi everybody, my name is Christopher Fodnelli, and this video series we've been working with the track builder in MotionView 2023. So this video what we'll be doing is we'll be creating our links and wrapping them around our rolling system, as well as doing some design edits. Let's get started. Going back to our model, what we're going to do is go to the track builder, go to create tracks, and in the wrap rolling systems, we're going to have our parent system set to model and the material set to steel, but we can always change the material to any default materials present. Next, we want to name our wrap variable name and wrap label, so I'm going to name them to left. Next, what we want to do is input how many entities we're going to be wrapping the links around. So it's going to be 12 from the sprocket to all the rollers. So right now I am first starting with the left side. Later on we'll create the wrap for the right side. And then what we're going to do is view the chain and belt properties. Alright, so now looking at the belt properties, we have a single pin as well as a double pin. Double pin, you can enable the connector length and width. And so going back to the single pin, we are going to update the link length, thickness, and width to the properties shown on the screen. And we can see that the graphics are being updated for the rolling system. And what we need to do is update the number of links to the suggested links defined. We can also use CAD and HD graphics for the links. By enabling this option, what's going to happen is the links will be replacing the primitive geometries just like the rolling systems. And another thing to note is you only need to input one singular link, and that link has to be centered at the global origin, so 0, 0, 0. This is done because MotionView is going to take that graphic at 0, 0 and wrap it all around the other rolling systems. I'm going to bring that link graphic in, and for link degrees of freedom, we can have it between 1 and 3. I'm going to have it set to 1. We can also enable CAD graphics to have contact between the rolling systems, but for this example, the CAD geometry does have some open edges, so it will not work for the graphics. And then what I'm going to do is enable user mass and inertia, just like from before when we made our rolling systems. These graphics do not have any mass associated to it, which we'll be editing in a little bit. For this example, we're going to enable soft soil interaction. We can also have a rigid contact with a flat bed, or we can just have it fully disabled. I'm going to enable soft soil, and I'm going to enable a soil terrain file. And then I'm going to set the reference frame to the road reference frame from the beginning of the video series. Going over the soft soil terrain file, it is set as an RDF where we can have our units, our model properties, our parameters for the soil, and much more. And so for this is advanced properties for the track soil interaction. And going further down, we can see the road increment of the file, as well as 2 rectangular roof obstacles that we're going to have the vehicle undergoing. Going back to the wrap rolling systems, we can also change the belt contact properties. I'm going to leave them at default. And so now I'm going to hit apply, and we're going to have the system wrap around the left side. Then we're going to do the same thing for the right side. Alright, now let me just load in the right wrap, and once that's complete, what I'm going to do is save the model one more time as a new version. Now let's view one of the wrap systems. So let's go to the left system. We open that up, we can see there are 46 bodies. So these are all the link bodies that we described in the wrap rolling system. We have many contacts, so it's contacts between the link and each of the rolling systems defined. And so there are forces acting on center of gravity of each link, as well as graphics, joints, markers, outputs, and points, as well as 5 data sets. So the first one, left wrap details, they have the details that we input in the wrap rolling systems. The link plate thickness is different than the link thickness. This is just the plate, so by default it was set to expression. In actuality, it will be 12, so I just updated that, and I'm going to update the right side as well. Now what I want to do, I want to edit part of the sprocket system, so let me just first resize the model. And so that point is with the sprocket, it is supposed to be aligned with the teeth. As you can see, it's a little offset. So going to the sprocket left system, I can see that the radial teeth tip position is off by 20, is again defined by another predefined expression. I'm going to overwrite it. And so just knowing that I overrid it, I should always check it when I do any big updates. So I'm doing this for the left and right. What else needs to be done is the link, mass, and inertia properties need to be updated. These are the values I'll be updating. Another thing that needs to be updated is the link thickness. So what I have to do is go to left wrap details and update the link thickness from 120 to 80. This is done just to show that the predefined conditions can also still be updated after they're made. So now I need to go to the right side and update the link mass properties as well as the thickness. Once I did all updates, I'm going to save the model. And so this is a good stopping point for this video. Next video, what we'll be doing is we'll be updating the link geometries for the soft soil interaction. We'll be bringing in that soft soil as an RDF, and then we're going to run the model. That is all for today. Thank you and have a good day.